Good afternoon, everybody. My name is Michel Pottiez. I'm working at Numeka. Well, to briefly present Numeka, Numeka is an SME company located in Brussels. It is a spin-off of the University of Brussels, who was born in '92 from the result of the research of Professor Hirsch's department in CFD. And we are part of the CloudFlow project in the CFD experiment. The outline of my presentation will be that I will briefly describe what the CloudFlow project is, to then continue with the industrial relevance of bringing HPC CFD to the cloud, to continue with to explain what are the potential improvement in the industrial process that HPC on the cloud can bring, and finally to conclude with the cost benefit that all this can represent to the end user. So, as I mentioned, this CFD experiment is part of the CloudFlow project. The CloudFlow project is actually a project aiming at designing and building an infrastructure to allow the engineer to access services, engineering services on the cloud in such variety of domain as CAD, CAM, CAE, among which CFD, but also structural analysis and many other, and also tools like system or PLM. Not only would CloudFlow allow to access such a tool through the cloud, but also to combine them to create a complex, more or less complex workflow that will be a kind of coupling of these tools and chaining of these tools to build a more complex simulation tool, which is nowadays requires in engineering design. So the CFD, the CloudFlow project is about developing this infrastructure, and in that project, our aim is to bring our industrial CFD code onto the CloudFlow platform, and to demonstrate its effective use in a cloud environment. So these are the these are the partners within the project. Okay, let me now go to the industrial relevance of bringing CFD to the cloud. Well, CFD is computational fluid dynamics. It's about performing numerical simulation of fluid flow, 3D fluid flow around 3D objects like car, airplanes, but also engine, boats, or whatever, modeling combustion. So the range of applicability of CFD nowadays is very large. And effectively, CFD is currently used in industry, in many sectors of the industry, such as automotive, power generation, marine architecture, and many more. So what's specific to CFD is that such simulations are currently performed on 100 millions to the billion mesh points, which may, as you can imagine, require a kind of huge computing power. So we are speaking here about, for the small computation, hundreds of cores to the 1,000 or even 10,000 of cores. So bringing this CFD complexity to the cloud makes a lot of sense. So this is what the aim of this CFD experiment. So what we believe this CFD on the cloud can bring, and its industrial relevance is actually twofold. It's first for large industry who are already user of CFD, allowing CFD, enabling CFD on the cloud would mean for this industry to have introduce kind of flexibility in introducing computing on demand, which would allow to largely accelerate and intensify the use of CFD in their daily design process. But most importantly, for the second impact of this approach is that for SMEs, actually many SMEs, engineering SMEs, which can consist of 2-3 engineers, may not necessarily have access to this CFD technology because of the too high complexity of installing such a system in-house, maintaining the hardware. So enabling CFD on the cloud really will answer the SME preoccupation to have flexible and easy to access solution with flexible licensing schemes. So this is the industrial relevance of this. Now, how can CFD on the cloud improve the industrial process? Well, actually, CFD here, as I mentioned, may require huge computing power. So by enabling this kind of elastic access to computing resources, what we enable to the engineer is actually essentially two things. First, the engineer using more computing power will allow to introduce more geometrical details into his analysis, making the simulation even closer to the reality, so that the results that he extracts from his simulation gets even more and more meaningful, to a point that now wind tunnel testing may become obsolete with such a solution. The second advantage of CFD on the cloud is that the engineer will be able to actually put more advanced physics into the simulation, for example, by introducing more advanced turbulent modeling, which may require more computing power, more mesh points to go to the billion mesh point. So by enabling this, we are including more physics into the simulation, again, making such that the results we can get out of the simulation will be more accurate, and that the design decision will be more relevant for completing a product. Finally, what this CFD on the cloud allows is, even going further, is that to enable the automatic design optimization. Automatic design optimization is a field in which artificial networks is being used to kind of automatically find an optimum design in a certain design space. So the automatic system will kind of, through a numerous CFD simulation, will automatically find what is the optimum. So by enabling elastic and computing on demand through such a platform, we are enabling a daily usage of system design optimization. And in the scope of this experiment here, the aim will be to apply this CFD on the cloud to a hydraulic turbine, where currently our end user uses a classical approach, a desktop approach to CFD. So he's already a CFD user, but he typically uses CFD at one design point, which represents one CFD simulation. In this CloudFlow experiment, what we want to do is that we want to enable a complete what we call performance curve that will characterize the whole hydraulic turbine in its whole range of applications, which go then far beyond what the end user is capable of doing. So to conclude, what the cost benefit of all these technologies is, first, the saving on hardware installation. So it's you must know that, well, since CFD requires large computing power, it also requires dedicated HPC cluster, which can be difficult to install, to maintain, to upgrade. Every 3 years, such cloud infrastructure may be obsolete, so you need to renew it. So by putting all this on the cloud, so we kind of alleviate this kind of problem to the user, and essentially SMEs who cannot afford hiring IT guys to maintain such system, install the software, which can also be costly, get a license. So before they start to run, even before doing any CFD simulation, it can take a week or two before they get started. So this can rapidly discourage small SMEs from even trying to use the CFD. So by bringing CFD on the cloud, we really think that So the small SMEs will have the opportunity to try the solutions, and then in a convenient and conclusive way. So these are the two benefits that we see out of this project in the future of cloud to CFD. Thank you very much for your attention.